Hi, welcome back to Music Chemistry. This is electron configuration of Damstadium DS. All right, let's go ahead and do this. It has an atomic number of 110, and its atomic mass number, of course, is going to be 281. Since the atomic number is 110, that means we have 110 protons. And since it's electrically neutral, we have 110 electrons. And our neutron count is going to be 281 minus 110. That would give me 171 neutrons. Remember that S holds 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. We use the off-ball principle, which says we fill the lower shells first before we fill the upper shells, and then we use the diagonal rule, follow these orange areas down until we run out of electrons, which is 110. So it'd be 1s2, see that? 2s2, 2p6, 3s2, 3p6, 4s2. Whoops, I meant to put a 2 there. Why did I put a 4 there? I don't know. Crikey, I didn't like this Donald Duck looking one. There you go, there's a 6. Okay, sorry about that. You can have some fun here. 3d10. Yeah. 4p6. You make a flub once in a while. 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5. Oh, whoa, wait a minute. You know what? This is going to be an exception. It's going to violate the Maillon energy exception. So this is actually going to be 7s1. Snarls. And this is going to be 5f14. And we're going to add, 6d9. Yeah. Don't need that 7p yet. So there you go. Woohoo! Yeah, look at that. We got an exception here. So let's go ahead and fill this in. Hund's rules for over-limitation. Yep, just do the up arrows first in every suborbit before you do the down arrows, just like I just did right now. Pretty simple, huh? Oh boy. What do you know? An exception. Ought to like it when you're going up. Yeah, we do actually. Oh, you gotta love these exceptions. Exceptions are ones that you have to watch out for. Luckily, you have me doing these things, so you can see, hey, this one's an exception. And then, of course, we go figure that out. Hopefully, it'll be made plain clear. If not, some of these things are kind of, see them as exceptions, like, oh, okay, I don't get it, but okay, that's what you say. So, yeah, you have to look hard at some of these things here. Let's see if we can't figure that one out. We're getting close with these errors. The errors, Hund's rule often helps us solve these kind of mysteries. Okay, now we have 5d10. Yep. And we're almost close to that exception here. All right, now we know we have 5f14, so I can go ahead and plug this in and see. And then we'll come back to that 7s. I left that 7s blank on purpose because this is supposed to be an exception, so I want to see what's going on with this. So there's your 7s. So it says it's 69, so we go 1, 2, 3, 4, 5, 6, 7, 8. Well, normally we would have 2 here, but you're going to take the second one. See, you're going to take that one away from the 7s2. And you're getting close to filling in the 6D, so we're going to put it down here. So that's the new arrow right there. Okay, just let you know. Okay, that's why it's an exception. Okay, noble gas notation. Again, Rhythm. Rn is our nearest noble gas. And that's going to end in 6p6. So that's going to take up this entire chunk. Rn. Alright. Now, so we're going to put it in numerical order because we fill from the lower shells to the upper shells. So it'd be 5f14, be 6d9, 7s1. And our quantum notation. This is where it's going to get a little interesting here. So we're going to say it looks like it's in period 7, but remember it's n-1 because it's in the D block. So it'd be 7 minus 1, which would give me 6. So our n value is 6. It's in the D block, so it has a value of 2. The m value is 1. We're skipping over the 0, I guess because of the exception. And that's going to give me, of course, 1/2 on negative. So that's right, because we're actually skipping over 2, because we actually went from D7 with metallidium, and then Damstadium is D69, so that's why we skip over that 0. Okay, now, in case you are curious why we have an exception, look up this. It's called the Meilong energy exception. And these guys will give you a lot more information on that. So listen, you guys be snarly, and we'll see you later at Moosing Chemistry.